All right, 2.7 is two concepts in one. It's combining functions and it's compositions of functions. When you combine, you're just simply putting together. When you have a composition, it's taking one whole thing and plugging it into another. So that's why we're going to do this in two parts. Today's just combining. You're going to be adding, subtracting, multiplying, and dividing. So we're going to talk about the sums, which is adding, right? Difference is subtraction. Product is multiplication. And quotient is division. There's two ways that you guys will be asked these questions. You're going to be asked these questions in terms of x, meaning there'll be x's in your answer, or you're going to evaluate with actual numbers, which is a lot easier because we think better in terms of numbers than we do in letters. But the way that these questions are written, if you notice here, you're going to be given 2 or 3 functions. You're going to have to add, subtract, multiply, and divide them. This first one says f plus g of x. It can also be written f of x plus g of x. That means you are adding the two functions together. Do you notice that there is an x right here? That means all you're doing is combining like terms. You're getting it as simplified as possible, but you should have an x in your answer. And then we're going to talk about domain. You're going to have the same domain restrictions that we had when we talked about domain a couple lessons ago. If there's a variable in the denominator, if there's a square root, or if there's a square root in a denominator, a variable. So again, same thing if you're subtracting. It'll be either f minus g of x, or they'll pull it apart and say f of x minus g of x. You're just subtracting the two. All right, multiplication, they're right next to each other, f times g of x, or f of x times g of x, they pull it apart. And then you have division, f divided by g, or f of g divided by g. Now, g could go first, you got to have an h, something like that. But understand, there's 2 ways these questions can be asked. So we're going to go through 2 examples and the 2 different ways that the questions are asked. Here are my 2 functions. Do you guys see these 2 functions right here? You have your f function and your g. All right, we're going to do letter A, where you're adding them, subtracting them, multiplying them, dividing them, and stating the domains. And then we're going to do letter B, where we evaluate actually using the number 4. If I look at letter A, it says f plus g. So f plus g of x. Do you guys see the difference between that f plus g of x and this f plus g of 4? Mm-hmm. When there is a number at the end, that just says, oh, for everywhere you see an x in this problem, plug in a 4. You're not multiplying anything by 4. They're telling you to replace the x with the 4. In letter A, they're telling you to leave your answer in terms of x. That means you should have an x in your answer. So the way that you would answer something like this, what is the f function? 1 over x minus 2, right? Plus your g function, plus the square root of x over 1. If we're going to write this combined, we're adding them together. When you guys are adding, you have to have a common denominator, right? Mm-hmm. What would our common denominator be between x minus 2 and 1? X minus 2, perfect. So you have x minus 2 here. Look at your first fraction. We've done rationals already. I have 1 over x minus 2. Do I have to multiply the numerator by anything? No, I just have 1. My second fraction, I have to multiply the bottom by x minus 2. What you do to the bottom, you do where? So x minus 2. So I have the square root of x times x minus 2. There's nothing else that I can do here. I cannot cross out this x minus 2 with this one. Why not? Because it does, number 1, the whole number 1 doesn't have an x plus 2 with it. If everything did, okay, fine, you could. But x, square root of x times x minus 2 is one term. And it's attached to that 1. So that's it. That is simplified. You guys have combined those 2 functions and left your answer in terms of x. It's not the prettiest thing in the world, but that's fine. Now you have to talk about domain. I see 2 issues with domain here. What's one of the problems that you guys see? The x minus 2 in the denominator. All right, x minus 2 cannot equal 0 because what happens If I solve this, I get x cannot be 2. What happens when your x value is 2? Your denominator becomes 0. So if I was going to graph that, I would say, okay, here's 2 on a number line. I can use anything in the world over here, and I can use anything over here except for 2, right? Do you see any other domain issues? I see a square root in the numerator. Well, what do we know about square roots? Your square root has to be what? Greater than or equal to 0. So I have a second domain restriction. This has to be, x has to be greater than or equal to 0. So here, and anything this way. Where do they overlap? That is your domain. Do you guys see where the yellow and the green overlap? Yes. Okay, so what would your domain be? From 0 to 2. It includes 0. Does it include 2? No. And then it picks back up from 2 to what?
Infinity.
2 to infinity. Good. Now, I know that that is kind of difficult to see. We really didn't do anything new here. We just did a whole lot of stuff that we've done before in one problem. We combined functions. We used rationals to get a common denominator. We then found domain restrictions using our domain rules that we learned a couple of weeks ago. It's a lot that goes into that problem. Now, when you're working this problem out and you're evaluating with a number, which we'll do in a second, it's a lot easier. But let's do the same thing. But now we're going to do what to the two functions? We're going to subtract them. All right, let's see how things change and how they stay the same. My function, my f function is still 1 over x minus 2. Minus my g function is the square root of x over 1. So again, I have to get a what? Common denominator, which would be x minus 2. So it's 1 minus the square root of x times x minus 2. Is there anything else I can do there? No. Do I still have issues with my domain? Yeah. Did the issues change? No. So your domain is what? The exact same. It's the same here as it is here. I still have a variable in the denominator. That's the exact same one it was a second ago. And I still have a variable underneath the square root, and it happens to be in the numerator. So my domain is the exact same for that kind of a question. That makes sense? A little bit? We'll practice this a little more. All right, so now we're going to do the same thing, but we're going to multiply these two together. So f times g of x. Well, my f function is still 1 over x minus 2. My g function is still the square root of x over 1. How do you multiply, guys, fractions? Straight across, so 1 time, so I have square root of x over x minus 2. All right, is there anything else I could do to simplify here? No? Good. Do I still have domain issues? Yeah. Are they the same ones that I had the first 2 times we worked this problem out? They sure are. My domain is still the same. It's still 0 to 2, including 0, not including 2, and then 2 to infinity. It's actually a little easier to see when you multiply them together. I cannot have a positive 2 in the denominator, because if I do, my denominator would be 0. And then I have to have a positive number bigger than, it can be 0, but it's got to be bigger than as well, because I can't have a negative underneath the square root. Does that make sense? All right, let's look at dividing. F divided by g of x. So my f function is still 1 over x minus 2. Now I'm dividing by the square root of x, and I always like to write things over 1. Can I simplify that a little bit? What do I do? Keep, change, flip. Perfect. So 1 over x minus 2 times what? 1 over the square root of x. All right, so this becomes 1 over the square root of x times x minus 2. Can I do anything else with that? Nah, leave it. Does my domain change?
Yes.
Does my domain change slightly? How? Why is it a parenthesis now? 0 to 2, and then 2 to infinity. How come it's not included like it was over here? Because can you take the square root of 0? Yeah, you can. What is it? 0. Can 0 be in the denominator? No. So it changes a little bit. Good, very good. It's good critical thinking there, girls. Very good. That's hard. Now if we're going to do letter B, you guys are like, how come we can't just do all of the ones like letter B? I'm going to do it over here. I'm going to write them out real quick. It's F plus G of 4, right? F minus G of 4. F times G of 4. And F divided by G of 4. Now, again, when you have an X, when it's F of G of X, that means you should have an X in your answer. Here, they're telling you to go ahead and plug a 4 in for all the X's you see. So in this case, this is what you guys would show me. My F function is 1 over 4 minus 2 plus the square root of 4. Where did I get that from? I just plugged in a 4 in the F function and a 4 in the G function. Now this is a lot easier for us to do. If we simplify, I have 1/2 plus, what is the square root of 4? 2. It's 2 over 1, right? If I'm going to add these two fractions together, I have to have a common denominator. What's the common denominator between 1 and 2? 2. So if I multiply the bottom by 2, then I have to multiply the top by 2, and this becomes 4, right? So when you combine F plus G of 4, when you add the two functions together and you plug a 4 in for the X, what's your answer? 5 over 2. Perfect. You guys like that a little better when you use numbers? It's a lot easier to see. Let's do the same thing. I have F minus G. Am I going to get the same answer? No, you guys should not. If you're not doing the same operation, you should not get the same answer, so be careful of that. Again, I'm going to simplify. I have 1 over 2 minus the square root of 4, which is 2 over 1. What's my common denominator again between 2 and 1? 2. If we multiply the bottom by 2 here, then I multiply the top by 2. So when you simplify, 1 minus 4 is negative 3 over 2. You all see that? Okay, now let's multiply. I have my F function, do a different color. So I have 1 over 4 minus 2 times the square root of 4. So as we simplify this, 1 over 2 times, what's the square root of 4? So 2 over 1, right? What's 1/2 times 2? Just the whole number 1. Good. And now if we do F divided by G. So I have my F function, which is still 1 over 4 minus 2, divided by the square root of 4. So if we simplify this, it's 1/2 divided by, you guys agree it's 2 over 1? How do you divide fractions? Keep, change, flip. What do I get? 1/4. Good. A little bit easier when we use numbers. Yes, I understand that. The harder part is when you're evaluating or you're combining when you leave your answer in terms of X. So we're going to do a whole nother example doing the same thing. On your web assign tonight, I don't think the problems are as involved as these ones are, but I wanted to just give you guys something to look at because you're going to have to do that. Tomorrow we're going to take one whole function and plug the entire thing into the other function. It's a little more work, but nothing you got. Example. All right, example 2, I have with numbers, but I'm going to first do example 2 in terms of X. So if you guys want to rewrite it, you can, or you just follow along with what I'm doing. But my F function is negative 2x, so F of x is negative 2x plus 3, right? And what's my g up at the top there? 1 over x plus 4, okay. Now, when you guys go to do a problem like this, the first thing you should see, are there any domain restrictions in your F function? No, I can use any number I want, negative, positive, or 0, right? I don't have a variable in the denominator. I don't have a variable underneath the square root, and I don't have a square root in the denominator. Are there any domain restrictions in G? Yes. right? So just kind of be aware of that. So in the first example, we're adding the two together. So my f function is negative 2x plus 3 over 1 plus 1 over x plus 4, right? Agreed? Okay, common denominator would be what? X plus 4. So I'm going to multiply here by x plus 4. What do I end up having to do? What if I have negative 2x plus 3 times x plus 4? What am I doing? We're going to FOIL, right? So I have negative 2x squared minus 8x plus 3x plus 12. And then I have plus 1. Agreed? Okay, so let's just combine like terms. I have negative 2x squared. A negative 8 and a positive 3 is going to give me minus 5x, right? And then 12 and 1 is 13 over x minus 4. Now, guys, you're not asked here to now factor or anything like that. All you were doing was combining them. So you added them together. There's your adding together. That's perfectly fine. Now you have to say, wait a second, do I have any domain restrictions? Is there something the denominator cannot be? What number is the only thing in the world my denominator, my x cannot be? 4. Because what happens when it is positive 4? So your domain here would be what? Negative infinity to negative 4 or positive 4? Positive 4. And then 4 to infinity. Any number in the world except for 4. You have, what's wrong? What's 4 minus 4? I see what you're saying, Marcel.
Yeah,
because I wrote this, that should be positive, right?
Yeah.
Okay. Guys, if I make a silly mistake like that, you got to tell me. In my mind, I was like, negative what can't be. So, yeah, that's my bad. Totally. I changed, if you guys noticed, as I was doing the problem, I went from positive 4 to minus 4 in the problem just because, Monday. But there's no other domain restrictions. I don't have a square root anywhere. I don't have a variable underneath the square root in the denominator, so we're good. So now we're going to do the exact same thing, but now we're going to do what? Subtract. So I take my original f function. Is it always going to be f minus g? No, it's just the way I wrote it. So negative 2x plus 3 over 1 minus 1 over x plus 4. Again, what's my common denominator going to be? X plus 4. So that means I have to multiply here by x plus 4. Do I need to do all the work again? No, I can just say over here it's going to be negative 2x squared minus 5x. And then I had plus 12. This would be minus 1. So what does that become? So negative 2x squared minus 5x plus 11 over x plus 4. Okay? Does my domain change? No. I still have the same domain. I can use anything except for negative 4, right? Okay, good. Good. Let's go down and multiply these two together. All right, I have negative 2x plus 3 times 1 over x plus 4, right? You guys with me? So we multiply across negative 2x plus 3 over x plus 4. Is there anything else I can do? Can I cross off the x's? Why not? Because why? They're not the same. Look, this in the bottom here is x plus 4. If there was another x plus 4, then you could. But remember, addition, subtraction signs, they glue our terms together. So this would be as simplified as possible. Do I have any domain issues? Yeah, it's the same thing as it has been. Your domain can be anything in the world except for negative 4. Everybody okay? Yeah? All right, let's talk about the last one then. We're going to divide. When we divide, I have my f function, which is negative 2x plus 3, right? divided by 1 over x plus 4. Can I rewrite this as negative 2x plus 3 over 1? And then 1 over x plus 4. Sometimes you guys like to see that, so it's like an actual fraction with a numerator to denominator divided by an actual numerator denominator. But we're going to keep, change, and flip. So when I keep the first one the same, I have negative 2x plus 3. I'm going to change multiplication. Change to multiplication. And when I flip, what am I multiplying by? X plus 4. Do we know how to multiply this together? Yeah. Negative 2x times x is negative 2x squared. Negative 2x and 4 is minus 8x. 3 and x is plus 3x. 3 and 4 is 12. Combine like terms. Negative 2x minus 5x plus 12. What do you guys notice here about your domain? My domain now is all real numbers. Go through your list. Is there a variable in a denominator? Nope. Is there a variable underneath the square root? Nope. Is there a variable underneath the square root in a denominator? Nope. So there you go. You guys see that? It's not the most exciting thing in the world. I get it. But you guys, all stuff you guys can do. It's all stuff we've done before. You're just kind of bringing a whole bunch of things together. Now if we go up and evaluate using numbers, you guys are like, why can't we just do this all the time? All right, f plus g of negative 3. What is this question asking me to do? Plug in negative 3 for all the x's. So I'm going to take my f function, and I have negative 2 times negative 3 plus 3, and I'm adding it to 1 over negative 3 plus 4. All I did was just take the negative 3 and plug it in for all the x's I see. So now if we simplify inside out, guys, what's negative 3 times negative 2? 6, and 6 plus 3 is 9. Plus, what's negative 3 plus 4? 1. What's 1 over 1? 1. What's your answer here? That's it. Good. All right, be careful of this next one. Does it say f minus g like we've done 100 times? No, it says g minus f, so the g function goes first. It's 1 over negative 1 plus 4 minus negative 2 times negative 1 plus 3. So simplify each parenthesis first. What's negative 1 plus 4? 3, so this is going to become 1/3 minus, what's negative 2 times negative 1? 2, and 2 plus 3 is, there you go. If I have two fractions, I have to have a common denominator. So what is my common denominator between 3 and 1?
15.
3. This is going to become 15. And then when I simplify, what's 1 minus 15? Negative 14 over 3. Good. So now we're going to take the two functions and do what? Multiply and plug in what for x? 5. So I have negative 2 times 5 plus 3 times 1 over 5 plus 4. Negative 2 times 5 is negative 10. Negative 10 plus 3 is negative 7. Whenever I have a whole number and I'm dealing with fractions, I like to put it over 1. So then I'm going to multiply this by what? 1 over 9. So when I simplify, what do I get? Negative 7 ninths. Good. All right, and my last one. F divided by G. And I'm plugging in 2. So I have negative 2 times 2 plus 3 divided by 1 over 2 plus 4, right? Okay, simplify your numerator first. What's negative 2 times 2? And negative 4 plus 3 is negative 1 divided by 1 over 6. How do we simplify this? Keep, change, flip. What's my answer here? Negative 6. Good. Good, good, good. Questions? No questions. All right.